Hello, I welcome you all to this another interesting screencast, and the problem reads, determine the force in members DC, HI, and JI of the truss. State if the members are in tension or compression, and then suggestions have been made to use sections S and T to find those member forces. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right, so since we are going to use two sections, if we took section S, then we'll be just working on the upper section. We can take moments about D to find HI, and we can also come and take moments about H to find DC, or sum the equations in the Y direction. Then we'll come and take another section T. For section T, we'll need the reaction forces here, the By, Ay, and Ax. And then we can come and take moments about C, because by then we'll have already found what HI is, so we can find IJ or JI, right? Great. So then let's do that. So we need to first find the support reactions, since we are also going to use the lower section. So let's draw the free body diagram. So we expect there AY and AX like so, and the roller there we only expect one reaction force, which is just By. Okay, so let's apply the equations of equilibrium. We have summation of moments about point A equal to 0, and clockwise being our reference. What do we have? We have By by 12, okay, and then we have this one is a positive moment. Then we have plus 1200 by 9, right? And then we have a minus 1600 by 9 plus 12, which is 21, right? 21, okay, equal to 0. Okay, 6 and 6 and 9, 21. Great. So now By therefore is just going to be equal to, we have 1200 by 9 minus 1600 by 21, then divided by 12. So our By is just going to be equal to 1900 pounds. Okay, 1200 by 9 minus 1600 by 21 divided by 12, 1900. Then we have summation of forces in the Y equal to 0. Okay, what do we have? We have AY plus BY minus 1200 minus 1600 equal to 0. We've already found what BY is. BY, so our AY therefore is just going to be equal to 1900 minus 1200 minus 1600. AY is equal to 900. Okay, just checking. Great. Then summation of forces in the x direction equal to 0, and then we have AX that's equal to 0 pounds. Okay, so we found the support reactions. What we need to do now is to do the sections. So let me just write them down. AY is 0, AX is AX is 0, AY is 900, BY is 1900. So let's make a section. Let's make section. We start with section S. We start with section S, which is this one. Great. So we are going to use the top section. So we'll take moments about D to find HI. Then we can later on take moments about D to find HI. Then later on we can apply the summation of forces in the Y to find DC. All right. Let's draw that quickly. So we'll have something like this. Okay, something like this. Let it come maybe somewhere here. It comes here. Maybe that one proceeds to that point. Then we'll have this like this. Then something like this up to there. Then we'll have this like this. Then something like this. I'll cut it later on. Something like this. Okay. And then one member down there like so. Then another one like so. Great. So I think that one is cool. It's fine. Okay. And then we have this joint here. This one is a joint here. And then let's do the cutting, just making dotted like so, to just show that we have done a section. All right, so this one is G, and we have a force there which is a 1200. This is F, and this is E, and this is G, and this one proceeds up to somewhere there. This one is I, and this one is H. This one also proceeds up to somewhere there. This one is C. Great. So this is how the section was made, and this is J here. Great. So at this point, we are going to, of course, indicate the load there, which is 1600. And then let's also assume the directions. Let's say this section, let's say this is in compression. Let's say this is in compression. Okay, and also this one in compression. This is HJ. Let's say this is HJ, and this is DJ. Okay, and let's say this one is in compression also, and this is HI. Okay, let's assume this also to be in compression, and this DC. All right, and then let's indicate the dimensions. So from here, from G like so, from G to there, up to there, and up to there, and then there, and also there. Okay, as well as this length here from D to E up to there like so. Great. So let's label that. So this is 9 feet, and then this is 6 feet, this is 9 feet, and this is 6 feet. Okay, so we are going to take moments about point D. DC and DJ and HJ will not have an effect, or it will not cause any moment about point D because their lever arms are equal to 0. So we have summation of moments about point D equal to 0. Let me just draw a boundary here, like so. Right. So what we have, let me just move this there. So we have about D, we have a clockwise 1600 by 9, okay, and then we have a plus 1200 by 21, okay, and then we have another negative due to HI by 12, right, by 12 equal to 0. Then HI is therefore going to be equal to, where is my calculator, minus 1600 by 9 plus 1200 by 21 divided by 12. So this gives us 900 pounds. And the direction we've assumed is in the correct direction. Okay, so we'll take summation of forces in the Y. You could also take moments about H to find DC, or take summation of forces in the Y. Okay, whichever. So let's take summation of forces. We have a minus 1200, minus 1600, and a plus HI and a plus DC equal to 0. We've already found what HI is, so we can feed it directly there. And once we do so, then we'll find that our DC is just going to be equal to minus 1200 minus 1600 plus 900. This gives us a 1900 pounds, and is also in compression. So let's draw another section which is section T there. So we are going to use the bottom section. So let's draw that one. Okay. So let's say we are moving from, let me get an aid of a straight line. So we are moving from there to there. 1, 2, 3, 4. Okay. Then down like so, maybe up to there. This is good enough. And then from there, let's go there. Then we come back there like this. Then we have a little bit of this portion up, and this side, and a little bit of this, and this side. Okay, I think this is good enough. We can move this a little bit down, maybe up to there. Great. Let's use our straight lines up to there. Great. So here we do have the reaction force. Before we do so, let's draw a line that just demarcates our dimension. There to there to there, so that we have these parts. Okay, and then also this height here, we need this height, as well. Alright, so we have another force there. So these two forces, this one is 1900, and then this one is 900. I can write it down there, right? This one here is 900. Okay, 900. Okay, this point here is B, this one here is A. Then this one here it is K, this one here is I, and then this one is C. So this force here, this one here, we already found it, because if we are to take this one up, it goes up to somewhere there. This point we are calling it H, and also these points they meet somewhere. This point here, we are calling this point as J. Great. So we found this force HI, and we said this is equal to 900. So let's assume this is also in compression. This is what we are looking for, in fact. Let's say it's in compression also. Okay, let's say it's in compression. Then let's call this one as JI. Okay, JI, and when we look at the angle, we have 6 on one end, 6 on the other end. Therefore, the slope here is 45 degrees, right? Great. So you've seen dimensions for this slope, they are the same. From I to H it is 6, and then from I to H is 6, and I to K it is 6, 6 to 6. The run of 6, the rise of 6, therefore this angle is 45. This is a 45, it's the same with this one here. Alright, this one here also we already found it. Okay, this is equal to, this is DC. If we remember this, we found this point goes up to somewhere there, that point is D. And we found this value here as DC equal to 1900. And then let's assume this one also to be in compression. This one here we can call it as our CJ. Okay. We are going to have, let me just create a boundary here. I create a boundary like this. We are going to have two components for JI. We'll have one component like so. This component is JI cos 45. Okay, JI, and then we'll have another component like this, and this one will be JI. Okay, we'll have that component. Let's call this component as JI sine 45. Okay, these are the two components. So what we are going to do is we are going to take moments about point C to find JI. And when we do so, CJ will not participate, 1900 CD is not participate, the support 1900 will not participate, and the horizontal component JI cos 45 will not participate. There are moments about point C will be equal to 0 because their lever arms are equal to 0. The only forces that will participate is the support 900 AY as well as HI 900 and the components of JI, which is JI sine 45. So summation of moments about point C equal to 0 and clockwise being our reference. What do we have? Let's start from the support. Moments about point C will have a negative moments 900 times. What are these dimensions? This is 6 feet. This is 6 feet. And this is 12 feet. So 900 by 6, by 12, about C by 12, and then HI, which is another 900, to be 900, this one is giving us anti-clockwise 900 also by 12, and then later on we have another component of JI, which is JI sine 45 by the lever arm, which is also 12. equal to 0. Okay, therefore Ji is going to be equal to, Ji will be equal to, Ji is going to be equal to this component 900 by 12 minus and the other one. So the two, they will give us zeros, okay? Therefore, Ji is just going to be equal to 0 pounds. Alright, so let's outline the final solutions. We have HI, which is in compression. HI is in compression and it's a 900 pounds HI. And then we have DC. DC is in compression and it's a 1900. And then we have JI, which is just a zero force member. Alright, I think this is really about it. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.